This is a lecture on the calculator 9-1 problem example 9-2. This is the college sports, and what I have done is, if you look under stats, click edit. I've edited my L1 and L2. Now the example in the book has n is equal to 50 for both, so it took some time to enter these. Remember, n is equal to 30 is your magic number where you don't need the original distribution to be normal in order to run any of these tests. So I've entered my L1 and L2. I quit this menu. I go under stats, over to calc. The two sample z-test is the test that we're going to run for 9-1. So you push enter, and then you have two choices. You have your stats, you have your data. If you're given a data, click data. If you're given statistics, push statistics. Now in this case, it's asking for the standard deviation. It's a 3.3 for both of the populations, and then it's asking for lists. Now by default you should have an L1 and L2, or the list button is this one. So you'll go second list, and then you can choose L1, L2, L3, or whatever other ones that you have. If you're gonna go down, keep frequencies at 1. You have a choice between a two tail, a left tail, or a right tail. Make sure to run a correct tail test. And then notice these arrows popping up. You see right there? I'll show this on the bigger screen. This arrow means that there's more stuff on the bottom. So I'll click down, and this arrow up on the screen, that one says that there's more stuff on the top. So you push calculate, and it calculates a few things. Notice that the z-score that we got is off in the first decimal place. It rounds correctly only to one significant digit. That means that they have done a lot of rounding on the way to this answer in the book. So the z-score that I'm going to be looking for is 0.94, not 1.06. Now the p-value is not 14% either. It's 17%, even worse. But notice that with this two sample z-test, we also have some interesting information popping out. I'll show this on the bigger screen. It calculates the one variable statistic for you, meaning it's going to give you the sample mean for the first sample. It's going to give you a sample mean for the second sample. It'll also give you the standard deviation of the first sample. It'll give you the standard deviation of the second sample. I will scroll down, and I have N1 and N2. This is how you're going to check whether you missed anybody, or maybe you've entered something twice. Because you have 50 entries for the first sample, 50 entries on the second sample, so you check back with the book to make sure that you got all of them. And you definitely want to write down your one variable statistics, because at some point it might come in handy. For example, if your x bar 1, your sample 1, is clearly larger than sample 2, this is why everything came out positive, is because we called my sample 1 males. The average there is 8.56, and then the second sample is females, which is 7.94. Now it is smaller. The question is it significantly smaller? And the answer is no. There is no significance in the test, meaning that even though we could see that males do have slightly higher average than females, it is most likely to be due to chance rather than an actual difference. It is not possible to have x bar 1 absolutely equal to x bar 2. It will never happen in reality. So you will always have some difference. The question is the difference significant or not? So this is how you run this on the calculator. Notice that whether you use approximations or you use exact numbers from a calculator, the 17% is still pretty large, so the final result should match with the answer in the back of a book, meaning do not reject the null hypothesis, not enough evidence to support the claim that the colleges offer more sports for males than they do for females. This concludes this example. On the next example, I will continue on to confidence intervals.